Welcome, everyone. It is my privilege to welcome you to the gastroenterology track of the conference. I'm Raj Pumadi. I'm a gastroenterologist and also the Chief Quality Officer with Kaiser Permanente Northwest in the United States. We have an exciting program lined up for you over the next 2 days. Broad suite of applications are being developed and tested in gastroenterology, ranging from the more well-studied polyp detection, computer vision, to the relatively new, obscure ambient intelligence and ergonomics of endoscopy, ranging from disease prognostication models to evaluating liver fibrosis, and also even matching recipients to donors in liver transplant. The applications of AI in GI are endless. And so this is truly an exciting period for us. Today, we'll start off with the primary component of machine learning or AI data. So our first track will be around data issues in AI. And then the second track, we will move on to clinical applications of artificial intelligence in GI. So you'll hear from thought leaders and exciting speakers. After the speakers finish their presentations, we'll have an opportunity for a live roundtable panel where you'll have an opportunity to ask the speakers the questions and engage in discussions. So we look forward to the first track, that is the data issues in AI and GI. I welcome you to track 1, data in GI. As we know, data is the oil needed for combustion engine of analytics. As Andrew McAfee put it, the world is one big data problem. This is very true for gastroenterology, where the scope of AI in GI is enormous, ranging from widely studied computer vision in endoscopy to others such as disease prognostication in liver disease, inflammatory bowel disease, and quality assurance surrounding endoscopy. As the applications are diverse, so as the data sources, including still images, video images, structured EHR data, unstructured clinician notes, endoscopy reports, and even patient-reported outcomes. So I would like to invite two of our experts today to talk about the opportunities and challenges associated with data for AI in GI. To begin with, I would like to invite Dr. Sebastian Zecchi, who is a consultant gastroenterologist at St. Thomas's Hospital in London. His research interests include upper GI physiology, upper GI cancer, natural language programming, and quality metrics in endoscopy. He co-leads the GI Data Sciences Institute in London, and he's here to present the Endominor. So the floor is yours, Dr. Zecchi.
Thank you very much for that introduction, and thank you for inviting me to come and talk to you today about a project which I think has been a labor of love for me, but it also epitomizes the approach, I think, to how we should be manipulating or cleaning our data before we get to any of the more interesting downstream functions and apps and programs that artificial intelligence promises. Gastroenterology is full of data in a number of different forms. I spend most of my day endoscoping patients, and so during that endoscopy, I have to record endoscopic findings, which are recorded either visually and or in a text form at the end of the procedure. I may take biopsies, and then I might wait for the results of those biopsies to come back, often in text form, and then I have to go about and interpret those biopsies along with the endoscopic findings. Of course, we have a number of questions in gastroenterology that we need to answer, and that really relies on these often semi-structured text reports. How many patients are we endoscoping with a specific problem? How good am I at my endoscopies? When should the patient be followed up? And so on. And a lot of these questions are in fact formal reports that we have to report back to our governing bodies, or they may be formal audits, and they take a lot of time to put together. A lot of these reports may need statistical analysis, and the hope is, of course, that many of these reports might be available to interpretation with artificial intelligence. But at the moment, and I would say this is probably true in most trusts in the UK, much analysis is done manually and crucially is not done reproducibly. But it's obvious to me that many of these questions fall into silos. We are interested in procedure quality metrics as a whole. We're interested in diagnostic yield metrics, surveillance metrics, which is to say, when should patients be followed up, as well as operational metrics like how many patients are going through the service, how much do we have in terms of resources of dealing with these patients. Actually, if you think about data in spreadsheet form, and then you apply these questions onto that, then many of these silos can be answered just with a proper ordering of the data, which is to say, for a patient, if you have the endoscopy report in its semi-structured form, if you merge that with the pathology report, and that merging can be difficult if you're doing it in an automated way, but if you merge it with the pathology report, then you can answer things like your quality metrics, because you can get that straight from the endoscopy or pathology report, diagnostic yield metrics, because that relies on both, surveillance metrics, because that again often relies on having information from the endoscopy and the pathology data over time, as well as patient flow as you're looking through the patients going through your service. So the organization of data is crucial, and the organization of different data sets, which is to say the merging of different data sets with data linkage, is also crucial. So this was really the starting point for the development of a package which I'd written entirely from scratch in R, called EndoMiner. And the function of this package was really to extract information and clean information and make it readily available for downstream analyses from semi-structured endoscopy reports and semi-structured pathology reports. So I wrote the entire package from first principles, the reason being, firstly, that there was very little that was available specifically for gastroenterology, and even more specifically for endoscopy. It also allowed me to understand some of the nuances of natural language processing and natural language programming. And it also gave me insight into the types of information that we could realistically expect to extract without any ambiguity about the end result. So as with, so I thought it was worthwhile me showing you the process that underlies the package. So initially, the type of report I would be getting from endoscopy would be like this. So these are three synthesized reports, which is really just a kind of a big slew of text, which is separated maybe by carriage returns or headers, but nevertheless has a certain structure to it. But it is just a big bunch of text, I suppose, with a structure. So the first thing to do is to obviously ingest this into the package. And then there are simple things that need to be done in order to clean the data. So sentences need to be split. Much information is contained within a sentence as opposed to between sentences in medical reports. There are linguistic processes such as lemmatization, which simplify text. Spell checking is crucial, and spell checking can be very problematic, and is one of the reasons why keyword search is insufficient for much automated language processing. Terms need to be mapped. So I may have done a radio frequency ablation procedure on a patient, but I might also on the same day call that procedure an RFA. I may call it Halo. So all of these need to be mapped to a single entity across all of the procedures and the different types of procedures in endoscopy. And of course, negative extraction is incredibly important, because that can skew your audits. If you're just doing keyword detection for certain entities, then the absence of that entity within a sentence will skew your audit data. So that's really most of the heavy lifting is done by those linguistic pre-processing steps. Of course, once the data has been extracted into its individual columns and cleaned up, then of course the data columns need to be formatted correctly. So you need to know what's an integer column, what's a text column, and what's a date column. Dates need to be matched properly, and they need to be properly parsed, which can be very difficult. Particularly in the UK, we often use a mixture of either US dates and UK dates, which can cause a great deal of confusion because the days and months are interchangeable. And then once that's been done, then there are a series of functions in the package which look specifically at endoscopy related entities, which is to say, extracting the endoscopist, cleaning up the name of the endoscopist, extracting instrument types, different medication and sedation that was given, and different events that happened during the endoscopy, like clipping and so on. This entire process is also carried out separately for pathology, which has its own nuances and its own lexicons associated with it. And of course, these two data sets are merged together based on the unique patient identifiers as well as the dates. And then downstream from that, the package includes analytic functions that are specific to endoscopy, such as can you detect, can you calculate an adenoma detection rate, dysplasia detection rates, etc., in different disease entities. And then there are some other functions that present the data. The real take-home message for me when designing this package was that if you design these kinds of things, they have to first of all be modular. So this is a package that I could swap out the lexicons for endoscopy, and I could input a different lexicon for bronchoscopy, and the entire package would work just as well. And I think that's important if we're designing packages, that we try and make them as generalizable by using modularity, by making them as generalizable as possible, and in particular by using a lexicon-driven approach, as I've demonstrated. And of course, because this is all scripted, the entire process is reproducible and documented. So I've also become very aware of clinicians' resistance to getting into the code underlying many of these analytic packages. So I designed a user interface to try and get clinicians used to the process of churning data a little bit, and maybe getting some clinicians excited enough to actually get into the code. So the Endominer has a user interface which just requires 3 clicks in order to analyze the data. So there is a clean and merge button which asks you to upload your 2 data sets, so the endoscopy and pathology results. The data is then merged, and then the user is just required to map the terms. So in other words, you have to tell the software which column represents findings, endoscopic findings, which columns represents pathological diagnosis, etc. And then it will do everything else for you. And then the analysis is separated into individual disease processes. So if I can give you an example, this, for example, would be one of the dashboards associated with polyps. So you can see here, I've removed the names, but along the bottom would be the endoscopist, and then you would get an idea of how many high-grade dysplastic polyps did I detect, how many were adenomas, et cetera, et cetera. There's a drill down table which allows you to look at your individual statistics. And then there are things like colored heat maps, et cetera, that tell you about the number of patients going through. So this is available for Barrett's, for inflammatory bowel disease, for eosinophilic esophagitis as well. And then the other thing that it really outputs are personalized endoscopy reports, which have been very important to maintain standards in the UK. So we output, using the software, a report that will tell you certain key performance indicators based on particular diseases. So for example, in Barrett's, we need to make sure that you have documented certain things like Hyde's hernia, the Prague score, etc. And it will give you an indication of that. It'll tell you how many biopsies you're taking for each indication. It'll tell you the size of the biopsies to make sure you're doing them adequately, and so on and so forth. So that this part is really a demonstration of, once you've cleaned the data, you can start to get some really informative statistics. But the cleaning, particularly of text data, needs to be taken very seriously and robustly. So the entire package is now part of a grant which has been supplied by the Health Foundation in the UK, with a particular angle at looking at whether we can use the extracted data and associate them with the images. So in other words, you have the endoscopy report, the pathology report, and the endoscopic image all lined up for all of your endoscopies as a way of improving lesion recognition for trainee endoscopists. And that's currently work in progress. The package is, of course, and I think this is important, is of course open source under an MIT license at the moment. So and really the importance of that is to encourage contributions to these kinds of packages to adapt, adopt, change them according to people's needs. And I think that's really the most accelerated path to getting these kinds of data munging programs up and running and used by lots of people. There's a very good documentation that I spent a long time putting together that explains each of the functions and how to use them. And it's all available through the URL that's at the top of the screen. A lot of the functions have undergone validation, and again, I would say that's an important part of software development in healthcare, is to validate the information that's coming out. So there's a series of abstracts and papers looking at the efficiency of extracting information in Barrett's esophagus, inflammatory bowel disease, looking specifically at some of the linguistics, as well as an adenoma detection rates. So just to wrap up, there is always going to be future work. So the process of natural language extraction will always need to be refined further, especially as new lexicons come on board. There is a hope to start using this to extract in an automated way some OPCS4 codes in the UK. There is always going to be user interface changes that I'm keen on doing, and feature creep that will just go on forever, I think. And it would be lovely for it to be able to use this in other subspecialties. And I think the bigger picture would be really to try and integrate this as part of endoscopy software, so that we have a much more mature analytics module as part of every endoscopy software that comes and is done on the fly as endoscopy is reported. So I'd like to thank, obviously, Guy's Thomas's, where I work, but also NHSR, who has been instrumental in developing this package, as well as the Health Foundation. Thank you.
Sebastian, thank you very much for that excellent talk. I do have a question for you. Yeah. And for example, in the United States, there are different ways of dictating an endoscopy report. The challenge around quality measurement surrounding endoscopy has always been trying to combine these different endoscopy formats. Some are dictated, some are done using good, well-made templates like Provation, some are just typed as free notes. And then we have pathology databases that may or may not integrate with the endoscopy report. So these are the challenges surrounding, for example, in my organization, which is a pretty large integrated healthcare organization, endoscopy reports are predominantly free texted. And then we have a SNOMED pathology database. So when we want an adenoma detection rate or either quality metric, we're having a lot of problems even serving up basic quality metrics. So would like to know more about your thoughts on how, you would address this problem of different endoscopy templates and, the pathology template being almost free text.
Yeah. So I would say that the problem becomes much less of a problem when you're just dealing with when you're converting everything into just text form, right? So the package doesn't integrate a template with a Word document or anything like that. Everything is just text, and the user defines the separators. And then because everything is just text, then the merge is very simple. So there is no problem with different file formats and so on, because everything is just flattened out into text form.
Okay, that's very good. That's very interesting. Thank you very much. And one follow-up question I have for this is, colonoscopy quality is very well defined, probably the most studied quality metric across the world for as far as endoscopy is concerned. Yeah. Have you had any thoughts about extending this to more advanced procedures like ERCP or endoscopic ultrasound?
Yeah. So at the moment, the ERCP module is not very well developed, but the lexicon is growing. For endoscopic ultrasound, I haven't done it yet because I don't do endoscopic ultrasound, so it's kind of outside of my domain. But it wouldn't be difficult to extend it. I think with any package that you design, you have to have some endpoints that you're really keen on analyzing, and that really informs how you do the information extraction. So, you know, if there was an endoscopic ultrasonographer who was interested in specific outcomes, then it wouldn't be difficult to design a module that would be part of the package that could just extract whatever they want from them. Because most of the difficult stuff is cleaning text and standardizing it. That's just the difficult stuff. But the rest of it, the downstream analysis, is very simple to do once you've got everything cleaned up and sorted. And really, I think that's the part of the reason why I wanted to present Endominer, is because it is a bigger question of, are we doing enough to really clean up our data before we start putting it into CNNs, different types of networks and random forests and so on. Because as a professor once told me, rubbish in equals rubbish out. So if you don't attend to the starting points, you're going to end up with some crazy conclusions which, you know, inform our practice, which is no good. So yeah, I think, yeah, the cleaning data is crucial, but it shouldn't be difficult to extend it to other specialties in endoscopy, as well as other specialties that are procedural, full stop.
So I would like to ask you one more question. As you know, there's more and more, there's demand to do more and more in less time. So one of the things that, what we thought about EHR did not turn out the way when it was implemented. When EHR was developed, the promise was that it would reduce workload on clinicians, but we all know how it went. So now there is a lot of cynicism around these machine learning AI systems. So what is your vision for something like Endominer in helping workflows in a day, in a workday for a gastroenterologist? Do you have any comments about that?
Yeah, so I would say in the UK we're also very overworked, but we're also expected to perform all of these analytics ourselves, often manually. The adenoma detection rates, for example, is a perfect example, because it used to be, up until the Endominer was implemented at the Trust, that somebody would go through all of the endoscopy reports and then go through all the pathology reports and then try and figure out, which ones had adenomas. And it was taking weeks. It was often a shared responsibility between a number of different consultants, often done out of hours, and that's on top of the extra paperwork and burden. So I think the process of automating analytics, particularly ones that are expected reports that should be going back on a yearly basis with no change to think that should be something that is automated. So I think there's definite improvement from that aspect. I think in terms of using information to increase operational efficiency, that has been a great deficiency in our use of data thus far. So a very good example of that is in Barrett's esophagus, where there's a lot of literature showing that the follow-up endoscopies for Barrett's are often done at incorrect time intervals, either too early out of excess caution or too late. And that's because people don't necessarily know the guidelines, or they don't have the information available to them. And so we're implementing at the moment an automated vetting procedure, which goes through the patient's endoscopies and pathologies, decides the timing of the follow-up endoscopy. And as long as that's manually validated, then adherence to guidelines is much better. So the workflow is more accurate and more appropriate, which means, of course, the resources are better utilized. So I think from those 2 points of view, it would definitely increase workflow. And I would say that every clinician, really, now the data has become more available through electronic systems, every clinician is really beholden on all of us to start to master analytics at some point. So we have in our trust, I've started setting up what I call data labs. So people that have questions that they want to ask of the gastroenterology data, they will come to me because I've got access to how it's done. But I won't just give them the data that they want. We will go through the data. I will start to introduce people to some basic principles of how the data is cleaned up and so on, so that there is an education embedded into the analytics process, and with the hope that will then educate them further on down the line. So I think these are all kind of very crucial bits to future-proof ourselves in gastroenterology and medicine as a whole.
Thank you very much. Thank you very much. Now we'll invite Dr. Thomas DeLange, who is an associate professor and senior gastroenterologist at the University of Gothenburg. He's also the chief medical scientist at Agur Medical, a startup company developing AI tools to improve quality of GI endoscopy. Since 2014, he has collaborated with computer scientists in developing AI solutions for endoscopy and has contributed to create large publicly available image databases for the scientific community. So, Thomas?
Ladies and gentlemen, good afternoon. First of all, I would like to thank the organizer to invite me to give this talk. First of all, I will give a brief overview of the GI tract for those who are not familiar. So I have just a topography with some corresponding endoscopic images. GI endoscopy and quality in GI endoscopy is extremely important because the aim of the examination is to detect lesions and later on to assess the detected lesions. And this will guide our treatment and follow-up of the patients to, for example, for the choice of medication, assess potential risk related to detection of the lesions, and maybe prevent cancer in the future and also predict some sort of long-term risk and prognosis of the patients. However, what is positive in the general population is the huge human variation in different talents, but in endoscopy, it's not that beneficial. So this is a major challenge for us. I will give 3 examples of this observer variation. This first example is about the detection of neoplastic lesions that can become cancer. And we know that 1% increase in ADR reduced the risk of subsequent risk of CRC cancer by 3% in following 3 years. And as you see from this study, the rate of adenoma detection rate varies from less than 5% in one endoscopist to 40 in another and all between. Another example is the assessment of mucosal inflammation in ulcerative colitis, a chronic disease. And if you are looking at the most important variables to assess the inflammation, it's a vascular pattern, blood in lumen, erosions, ulcers. And if we ask experienced and unexperienced endoscopists to assess the inflammation, we notice that the observer of the coefficients of variancy range in inexperienced from 45% to 72%, and it's experienced observers from 21% to 62%, and this is really substantial. Another example is the Paris classification that is aimed to predict the risk of malignancy in neoplastic lesions in the entire GI tract. And here is a study of internationally renowned experts when they assess this Paris classification. There are 9 different classes, and we can see that the kappa Fleischer range from 0.27 to 0.54, and this is almost like flipping a coin. So what is the potential role of AI in endoscopy? Here I will give the example in the adenoma detection rate. And the recommended target is 20%. In Norway, in the quality registry, it's 25%. But we think that we can aim to reach 35%. And with this, we will reduce human variation and will probably be able to reach the quality like the best expert. And this will assure the equity for all patients attending endoscopy. However, there are some essentials in developing machine learning, like ground truth, comprehensive annotated image and video databases, and the quality of the databases. So if you are looking at the ground truth, we'll see here, it's quite obvious that this is a polyp and this is a stool. I think the ground truth is easy to establish here, but in the case of this possible very slight subtle esophagitis, I think the observer variation will be quite substantial, and then it's difficult to establish the real ground truth. So how can we establish a valid ground truth? We need a sufficient number of expert annotators. And it is possible that we need the number, adjust the number of observer for each class. For example, if there are less variation or minimal variation, it might be sufficient with 2 to 3 annotators. Or if there is a large variation, we can maybe require 10 annotators. Another solution is to merge all the endoscopic finding with a histopathological analysis. But still, between pathologists, there is a significant observer variation. And of course, it also a risk of sampling error, that you're taking your biopsy at the wrong place. Another important requirements are large, comprehensive, multi-class image databases. And here is an example from our recently published Hyperquasir dataset. And we also know have impressed a Quasir capsule with also a large quantity of images from video capsule endoscopies. However, the quality of the database is essential. So for the resolution of the frames and also the rate of the videos, so we have full quality videos with a high frame rate, so it's reproducible. And of course, the number of images per lesion is important. So then we need to label the images and the videos, and there are different possibilities like global feature, bounding boxes, and pixel-wise segmentation. And it's also a question whether we need to annotate findings that are not very interesting, like bubbles and stool and mucosal folds. When I'm performing my colonoscopies, is of course a lot of different polyps, and I have different shapes, size, surface, and so on. And even within these different classes of the Paris classification, they are very different. So we need to have a representative selection and maybe more than 1,000 images of each subclasses. However, it's a challenge because of some of these classes are quite rare and difficult to collect. And another point is that the scope handling is different from endoscopist to endoscopist and might be a challenge for the detection and recognition of lesions. The last point I'm going to address is the loss of information when you are pre-processing the endoscopic images when they are entered into neural networks. So a standard endoscopic image is in HD, and then it's needed to be pre-processed to have a much lower resolution. And that will probably affect the detection of subtle changes, like the examples I show here. And here is the downscaled images, and you will observe that the tiny vascular patterns here that are very important to recognize these serrate lesions are nearly invisible in this downscaled image. So my take-home message is that there are still several quality issues when we are developing machine learning algorithms for endoscopy. And it's important to continue basic research, establish methodology for having a valid ground truth for all endoscopic lesion classes, the most important first. And then we need to determine how to detect subtle changes which may affect by the downscaling of the images. But nevertheless, I think that AI will become a game changer to improve the quality endoscopy to the best of our patients. Thank you very much for your attention, and thanks to all my colleagues that make all our projects possible. Thank you.